Hello everyone. This chapter we will introduce how to choose different types of boards and how to decide the quantity according to the site configuration. Well, we will give some typical examples to help us better understanding the eNodeB product structure. Well, this table listed 4 types of typical eNodeB configuration here. They have different sales number, bandwidth, and antenna configurations. Now let's see how to choose different types of board and decide the quantity. Here we specified the main processing board and the BBP board is LMPT and LBBP, which used inside BBU 3900 and only for LTE mode. So take the first site for example. This site configuration is like this, with 3 cells, and each cell working on the bandwidth 15 MHz or 20 MHz. And the site antenna configuration for each cell is 2T2R, means 2 channel for transmission and 2 channel for receiving. So for the main processing and the transmission board, 1 is enough. And for the LBBP, we can choose both serial C and serial D. Both serial can support this typical configuration. And for the RF unit, we specified here is 2T2R RF unit. So each RF unit can support 1 cell 2T2R. So here is 3 cells totally. Then we need totally 3 RF unit. The antenna, we need to choose a dual polarized antenna. So each antenna for each cell. Well, here, these 2 sites are configured as 44R. So let's check if it's 44R. For the LMPT, the same, only 1 enough. While for the BBP board, here we can choose LBBPC, 1 LBBPC board, and 1 LBBP-D2 for the 44R configuration. While other like D3 or D1 could not support 44R, so we could not choose other types of BBP. Well, I'd like to emphasize here, the LBBP-C only supports 44R on the TDD mode. So it's not support on the FDD mode. Well, for the RF unit, here need number 6, double the number compared with the first site configuration, because RFU is 2T2R RFU, so each cell we need 2 RFU combined together to support 44R configuration. And the antenna we need to choose another type with 4 ports. Well, let's check the last site. This site with 6 cells, so we only can choose LBBP D3 version. Only this board supports 6 cells. Now let's check how to decide the types for the U-serial board, UMPT and UBBP. UMPT, UBBP support multi-mode and can be installed in BBU 3910. So here, for the first site, this most common configuration, LTE configuration, we can choose D3, D4, D5, D6 as UBBP board, provide a baseband processing signal. While for the 44R here, we only can choose D4 and D6. And if the site is configured as 6 cells, we can choose D5 and D6. And the other part for the RF unit and antenna unit, the same with last slide. Now let's check the BTS 3900, this indoor BTS configuration under this 4 typical site configuration. Here, at the bottom, these 2 site with 44R 44R configuration. So this is with one cell. You can see here, we configure one LMPT and one LBBP as mandatory board. For the LRFU installed here, on the RFU cap subrack, we need 2 LRFU to support one cell 44R configuration. Now let's check for the blade side, how to decide the power distribution plane. If we configure 3 blade RRU, when the power input is DC power, we need one DCDU to distribute the DC power to blade BBU, blade RRU. While if the power input is AC power, so we need to configure OPM 50M and another SPM 60A. One is to supply power for BBU and RRU, and this SPM is to protect this OPM. You also can decide to add IBBS 20D as backup battery as optional. While if the site we configure 6 RRU, so for the DC power input the same, one DCDU enough. While if for AC power, we need double the number of OPM, SPM, and the battery, IBBS, battery backup system. This slide is about the RF connection. The left side shows us the site with 3 cells and the 2T2R configuration. We configure LBBPC as the baseband processing board and come out 2 CPRI cable to connect with each LRFU. Then each LRFU connect with antenna with 2 antenna jumpers, this blue cable. For the 6 cells configuration, here we need to replace the LBBPC with LBBP-D3. This board, one board can configure 6 cells. So here come out 6 CPRI cable connector with each LRFU respectively. And for the antenna part, the same. Well, for the RRU connection, this slide listed there are totally 3 types: star topology, train topology, ring topology. The first star topology is most common. Each RRU connect with different CPRI port on the BBP board. And this train topology, only the first RRU connect with BBP CPRI port, and the other RRU only connect with the up-level RRU. So this type of topology, compared with star topology, can save the CPRI resource, but less reliability. It's normally be used for the high-speed road, high-speed rail, because the RRU between each other installed far away, so can save the CPRI cable. While the star topology is more reliable, but occupy more CPRI resource. The third type is ring topology. You can see we can configure it as load sharing or backup mode for better reliability. For the load sharing mode, the RRU connect with different port, CPRI port on the BBP board. So both CPRI port, the bandwidth resource can share together to provide this cell configured on this RRU. Well, if we configure it as backup mode, we can configure as cold backup and hot backup. This type listed, we draw here. The cable connected come out from RRU, one connector with LBBP in slot 2, another in slot 3 in different LBBP. So this type is hot backup in different BBP board. So this type can provide better reliability compared with cold backup. So if this board is fault, the service can switch to another board, to another separate cable. For the transmission network of eNodeB, also we can choose different topology. We can choose star topology, tree topology, also twin topology. This star topology is most common, normally used in dense area. Each eNodeB connected directly with EPC through this transmission. While the chain topology is different, the eNodeB gets the transmission from the up-level eNodeB, and the up-level eNodeB also decides the bandwidth for the next eNodeB. So this type chain topology also used for the high-speed road, high-speed rail, this kind of site, can save the transmission resource. The benefit for star topology is it is more reliable and easy for engineering and maintenance. Well, that's all for this chapter's content, and also our whole course for eNodeB product is finished now. Let's have a summary. So on the first chapter, we introduced briefly about on the LTE SAE network architecture and pointed out the eNodeB position inside the LTE network. Well, so described the eNodeB product features and different application scenarios. And on the chapter 2, we introduced logical structure and hardware structure of BBU, RF unit, these two main components of eNodeB. And also we introduced the auxiliary devices for eNodeB production on chapter 3. And we just introduced the typical configuration for eNodeB. So that's all for the whole course. Thanks for your time.